Good. So now I'm going to share. Beautiful. So let's get going. Uh, Today we're going to really start diving. This is time, and I don't think you saw it, but next time I'll show you. This is a nice, simple application, which could be really useful when you want to show comparison of export and import. You see, when you click, you make the chart, and I just showed the people. I don't know if you saw it. The library Plotly. It's a free library with a lot of capabilities. It's JavaScript type. So let me close this one and let's go back to our stuff. We are in chapter 2. Remind you, we pulled the data. By the way, we tried to see the Excel. We had a problem, and very strange. I fixed it. I fixed that because the problem was really mostly in Windows. In Linux, you don't have that problem. So let me show you. There's a small change you need to make. It's amazing. It's you don't really probably it's on Linux. It takes it as a default, but if you want to read, remember we had if we want to read, we had load Excel data. I made this function, and we did in this function like we had those two functions. Remember load CSV and load Excel. This one worked nicely, and this one we had a problem with it last time. And it's really, this should be the default. This is the only things I added there. That was the problem. Why we got an error. Now, if you try it, it will work just fine. Okay. Remember, I tried to open Corona and it didn't work for me, the Corona data,
I'll see.
if you remember. So I fixed it. The only thing is that on Windows, it kind of required me to put this one explicitly. On Linux, that's why when ever since I write on Linux now, honestly, I don't use Windows almost. Rarely that I use Windows, by the way. So the only thing is just telling the engine use the Open PY Python Excel. So this is an excellent library, by the way. I did a lot of work using this library. But when I put it explicitly that the engine is this one, it doesn't use. Remember, he asked us to add this. He asked us to add this library. You really don't need this library. I left it there because we already installed it. But the one that we really mostly use, it's the Open PyXL. It's right here. Where is it? Let me see. One of the, here we go. This is the one that we use. So this one can open Excel, but if I don't tell him on Windows, he's trying to find this one as default. I put it, but it still didn't read it on Windows. So I tell the hell with it, this one. And I just told him, please do use this one. Don't use the other one. And that one does the work. So this is a fix up. I will upload a new version of everything, so don't worry about it. And it should work. So if you really want, you can just put this one. You see that? It just says comma engine equal to Open PyXL. And then everything should work just fine. Okay, let's go back. So that was fixed. If you want to make sure that I didn't lie to you, how can you check it? This is a good exercise. How can you check it? Let's go to chapter 2. Let's go here. Okay, and I can just I can in fact the truth of the matter here we have
Eight.
we inherit from Algo the init, and then we did some stuff here, whatever it is. We download it if we don't have the file already there. But by the way, these are the two things that I put here. So I can read the Corona. This time I'm using Excel. This time it does work. It turned out it's bringing me data frame, and I print the data frame. Then I load the housing. So this is just to demonstrate to you that it does work. Okay, let me show it to you. Let me refresh. And when I do go, you will say I'm getting the data, it means it works. because it's also, let me just show you that it does. In fact, I'm putting the data frame. So if I go up here,
Yes, I think
go up,
Soro will not be there today.
yeah, here it is. This is the table, by the way. This is the corona table. It's every city. It has every city, how many cases confirmed, how many
Yes.
died. Oh, okay.
Yes, Soro said that it will not be uh, there today.
Okay, okay. Just tell him we have a recording. I will upload it and he can see it. Okay. I just want to make sure. I hope everything is fine with him. So, okay. So this is good. This is really does work. So I don't really need this. This was just for making sure that function works. So we know this is fine. We don't need it. Okay. We only focus on the housing. And this one, if anybody wants this database to play with it, or and you know, it doesn't really have enough. I would combine it. If I will do a machine learning study, it would be very interesting if there is any differences between, say, Georgia, Texas, Arizona, Nevada, all of those, Ohio, Virginia. It's all United States. If you see Alaska, one thing you can do is combine it with another base of a population and the population, then try to find out what might be the the reason of having a big. You say this is a big number, New York, but it doesn't mean having a big numbers is maybe it's a big state. I have a lot of people there. Okay, it's like, but on the other hand, when you compare it to California, which is very big state, in New York, I have much more people dying. So it might be the population. I have a lot of people. This is excellent. Could be a nice database for studying, but you most likely need to combine it with another database. You need another factor about every state and try to find out what could be the element that causing more death or more infected people in every state. That could be a nice study. If anybody wants to do that, I'll be more than happy to help. You see, you have all the states of the US. By the way, those are islands, Guma and Virgin Islands. They are not states really. Uh, um, so anybody that wants, that could be a nice one for analysis. Okay. Now, so this one is fixed, and let's go back to our first step. When we get the data, we said we got the data online. It's unzipped it, and after it's unzipped it, it's make it as a data frame, and here is the data. Please look at it. We have all numbers, longitude, latitude. It's really location of every district. This is each row. It's a district. Okay. Every row is a district. We have about more than 20,000 rows, districts in California. So here I'm just showing really 10 of them. And all of those are numbers, the median age of the house, how many rooms we have in every district per house, total bedrooms, populations, houses, households, how many people live in that household. Okay, median income. By the way, I will talk about that one in a minute when we explore the data. Median, it means how much money each family is making. 8.3 is meaningless. Is it thousands? Is it 100,000s? What is it? You will see that somebody have changed the numbers here. I will talk about it in a minute. That's the house value. This is in dollars. You can tell this is like $452,000, 600. And last one is very important variable because this one is what we call categorical. How close I am to the ocean. And there's several categories. We would like to see how many categories are there. Okay, first of all. And then I cannot really do a median. I cannot do standard deviation. I cannot do average. It's a category, nearby. I cannot do an average with other categories. But first of all, I would like to know how many categories are there. By the way, here we go. If you see, there's a command in a minute I will show you that you can get which kind of categories are there. There are really 5 categories, how close I am to the ocean. By the way, there are islands near to California. There are 5 islands. So they're really inside the ocean, okay? And near bay, near oceans, those somebody have made those categories. And there's all the districts, you know, so you have 9,000, most of them is really 1H oceans. You need really to see what the definition of each one of them. I don't really care that much as really, you know, about the island, it would be really hard. I have only 5 cases, okay? So maybe it would be hard for me to know how different is the islands just for proximity. 5 is already enough usually, but that's what we have. And this variable might not be the one to be as a good explanatory variable. It will not be really, you know, in a regular statistics, you will never run something with 5 cases. You will need at least 30. In machine learning, we can use it and get some sense to it. So that's the beauty about machine learning. How do we get this one in a second? I will show you. Then we have another table, which is really giving us all the statistics about every variable. Of course, this is a meaningless. You can say a really longitude. You can say what is the center of all the districts. Like this is really like the center of California, you can say. That's what the average, but this is a meaning. Usually I will ignore that, depends, okay? This is really important, okay? When I look at this one, how many houses, how many cases we have? As I said, we have 20,640 districts, okay? The mean of the age, how old is the houses in California? The average is about 28 years, okay, 28, 29 years. Standard deviation is 12. That means you have quite a variance. Very expensive houses, very old houses, very young houses. The youngest house is a year, okay, within a year. And the oldest one, it's 52 years. So this is really kind of give you a nice to see the range from 1 to 52. So I have all of them. The other one that could be really interesting is, you know, I have the median is 28. 28 is about a half, 26 is half. So it's okay, it's quite, but we'll see the distribution in a second, okay? And then this is the mean, but many times you also would like to compare the median to the mean, this number to this number. Sometimes if there are differences, it tells you the distribution is not, if those numbers are too different, that means the distribution is not symmetric. This is quite close, so it might not be symmetric, but it's close to symmetric, maybe based on this one, but we will look at the plot in a second. That would be good, but there is a command which in a minute I will show you, and you have everything in the code, which basically it's called describe, and you have info. You'll see it is really very simple commands that you can run, and then you get all those statistics, okay? And something, but one thing I would like you to notice, here it says, you know, 50,001, you see that? And I'm going to talk about it in a second. Here, in median income, as I said, 15 what? I will talk about it as well. Somebody have changed the number, they scaled the number. They turn them to be something like from 0 to something, okay? In fact, in here, it's really like, you can tell from a half. It changes from a half, this is the minimum. So it made the scale of income going from a half to 15. Is that the right way to scale it? Say the minimum, that's the minimum, and a half. So somebody have changed the income. I don't really care as a machine learning as long as they kept the proportion in the right way, but we see there's other problems in a minute and we need to fix them before we can start running algorithms to it. Here's another one. Households, how many people live in that? How many families in every district. So there's a big districts and there is a very small one, by the way. I don't know which one. This probably might be an island. Somebody owns an island or something like that. Population, it's moved from 30 people to many people, 35,000. So we have a big diversity on all those variables. This is really a nice stage number one. Just look at it. Okay, I just got an impression, but I don't really get enough. I know there's 5 categories and all of that. All the code, by the way, please do. I really, honestly, I think it's so important. I spent a lot of time to prepare this material. And as I did here, for example, you have the algo 2. And from the algo 2, when you choose get data, please notice I put a lot of print here in the printout. You see, and then only I transfer this stuff to the website so you can see it. But basically, a lot of the stuff you can see here, the printout. So please do look at it. It's very, very important. Let me do it again. You see, that's where that start. When I refresh and I choose get data, I get the data here, okay? But I also print a lot of things here. Many times, sometimes I don't really show it on the screen, as we will see later. Most of them I do, but please do follow this one. You see, all this is printouts that I put for you for. So let's look at this one. Okay, when I did the get data, what did I really do? Okay, I created the algo 2. It's pull the data and prepare everything for me. We know that after I prepare everything, the algo data, it really is my data frame housing. So just for, I printed to see 10 rows. So indeed, I do see the 10 rows. By the way, this is the same things I transferred to here. If you see here as a data frame and I printed. So this has helped me to print it on the web page. But this is, you know, as a machine learning, most of the people are concentrating on this stuff. And this one I call a smart machine learning. He knows how to present it also to other people, how to see it, how other people can see it too. So it's both of them, in my opinion, it's very important to know, but this is crucial. When you do machine learning, you usually, the first round, you always focus up, make sure you read and you see the results. And then you think about how to present it. So what do we see here? We see the data. This is really our data. We just see 10 rows. Everything that I saw before, I can see here. Then I go, after I saw the first head is a command of data frame. And I look at the 10, the first 10, then housing info, basically really give me a little bit information. If you look at this table, okay, you look at this table, you see, it tells me how many data I have about every variable. Longitude, latitude, I have 20,640, all of them to 20,000. This one has a lower number. You notice this one? Hey, why is that? Probably maybe some of the districts, I don't have data. That's what we call missing data. So all of the columns, we have 20,640, but for these variables, we're missing some data, like about 270, something like that. 270 missing data. What do we do with missing data? Should we throw away this? Should we throw it away? Should we fix it? And we'll see. In fact, I also, if you look at the website, I put a link there for you of 6 methods to deal with missing data. And for this course, we will use the median. But there's many ways. I use a lot of what it called the imputations using chain equations. It's more sophisticated. You can use it without really even understand how it works. It's a little sophisticated way how it works and get a very nice results. And there is also, in fact, if you have a very serious computer, you can use even deep learning algorithm. I made a link, I put a link for you to read whoever is interested in dealing with missing data. Most of the time using the median, it's not a bad idea. There's other method, as I said before, but as a start is always just to get the idea that you need to deal with it. use the median. It's not a bad idea. As we use the median, I also will teach you how to use a component of imputation, which is very important knowledge to acquire. Okay, now that I got here, I move on. Okay, now see this one, it tells me, look at this one, by the way, housing, it's my data frame. And when I write in parentheses ocean proximity, this is really one variable, one column. So I took the column of ocean proximity and I asked him, please give me how many value counts is a function that is of data frame, okay? And he really will count, it gives me the value and how many I have of each category. This is a good one for categorical variables as the ocean proximity. This is why I got this table, by the way. You see in ocean, I have 9,136 cases. So this is giving me all the categories in that column and how many of them I have. Like as I said before, islands, I have 5. By the way, for a regular person working like that, it's impossible. But for a machine learning, this is the way you usually will work. You look at the output here, and then when you finish and you know everything is perfect, then you do this one. That one, in fact, if you look at that, if you have a good eye, in fact, I use, you see this one here? You see this one? Okay. I have, in fact, I made even, I turn it to the frequency. Okay. So I turn already is this one, the count. I turn it to the data frame will be nicer for me and easy for me to print. While here, if you have a good eye, you can see that here I can print just the way it is. If I want to use another component I have for presentation, this is not a data frame, by the way. This is the result is not a data frame. This is not a data frame. Okay? This is not a data frame. Fair enough? But if I want it as a data frame, I convert it to a data frame, I transfer it to these templates, and I present it. But this is, I wouldn't worry about that too much. Honestly, and one point in time, you'll feel comfortable. You have more experience. You can, even if you don't know, you look in Google's and you learn and add stuff. The most important thing is really for now is to know this one. It's important that in data frame you have a function called value count, and for categorical variable, you can really count how many cases you have or how many rows, how many districts you have in each one of them. You know, almost half of them is one H ocean, okay? And so that's really what important. Then we have near the oceans or near the bay. Near the bay, it's probably San Francisco, all of that stuff. Near the ocean could be any place. No, it doesn't have to be near the bay, okay? So that's nice to see. Usually, it doesn't really tell me everything now, besides this island 5, but it's a good one to always to know how to use. Okay, let's go to the next one, which is again housing. Again, it's a data frame. Yeah, data frame also has a nice function called describe. Describe the data. And by the way, we saw that already in the output. Here we go. That's what it really does. It the mean, the median, the average, you know, the mean is the average, that's the median, as we talked about. All that one I also transferred to here, so we could, what do you see here? I transferred that one also to the template, and I just showed it to you, okay? That's really what the first click that we did here. When we click here and we got data, that's really what we got, those 3 things. And there was in fact one more that I didn't even show it here, by the way. I don't know why I didn't show it, but it doesn't make a difference. So beautiful. Let's go to the next one. Let's see, plot attributes. What do we do here? Now we get into a little more detail. We take every column here. We take every column. This one is really can't help me. The one with the near the ocean, the proximity. This one, I cannot make a plot of that. So I would like to make a plot of all of those ones and look at them. And by the way, you have all the code right here. Again, you close this one, open the next one, and here's all the code. Very nice. See the title, histogram of attributes. This one, you just see, this is really nice. The data is really our data, okay? And this is the data frame. Again, it's really is our data. This is the housing data. And when you do histogram, okay, of all of them, this is really nice. It automatically create this plot, okay? It's automatically creating this plot. This is really nice. It's already done in Panda. This is why Panda is a very important library in machine learning. Very important library. And this is beautiful. And so I told him, okay, this is really the size. It's just really you play with it. How do you want it to be? How wide you want all this histogram? How high? Play with it. Honestly, I just put 20, 15, or I played with it a little bit until it looks nice. So that's what you usually do in life. By the way, because I know that I'm always, after I do the plotting, this is really created the chart, this line. I just give it a name and then I save it. And as I told you, we have a function called save figures, which keeps all the images automatically for us. So if I go here, I don't even have to think about it. Every time I create a plot, I can take a name, put it inside and save it. And he will put it for me. Where will he put it for me? We already know. He will put it in the images. And he will put it in chapter 2 because we are in chapter 2. So what the name is going to use, for this one, it's exactly this name. So let's look at by the way, you will make a file like that called attribute histogram plot. Here we go. This is it. I double click. If you double click, okay, you see this really is the image. The only thing is, you see, this is really what is creating automatically. By the way, the plot, you can use plot show if you don't know how to use this one. That's what a lot of programmers do, and I think that's stupid. This is much better. And you just make one function, you keep it, you have it there. You don't have to run it every time. So, and then all what I have to do is just really show it in this template. And that's, you can play with it and look at that at home. Please do it once. It's a good exercise for you. Please do. What do I mean by when I tell you look at that? I mean, go to the applications, okay? Go to the introductions to machine learning, go to the templates, and under the intro, you will see in chapter 2, okay? By the way, if you look at that, that's what I did, intro chapter 2. And then I told him, give me this one, attribute histogram plot. You see, this is it. And then I just transfer all those variables. Look at the first one, just learn it once. This is a good exercise, it's so simple. Look at that, there's almost nothing, okay? Nothing, there's really nothing. It's all it is. A div, a title. What will be in the title? We'll just put it there like Django. And this is the only things, but see, this is so beautiful. You don't even have to think about it. The static, its basic static is automatically knows how to get to up to here almost. Then after the basic static, it goes to the intro, it goes to data. Where's the data? What did I do here? Right, it's not this one. Intro chapter. Then I have pictures, a ping. Hold a second. So this is the chapter. This is images. Where's images? This is the chapter. Let's go ahead. No, not this one. Sorry, my mistake. I meant here. Yeah, this makes sense. I have intro. That's right. I have the basic. The basic is already going right to the static. You see, this is the basic static. Is already automatically will take you to here. Then you go to the intro. Then you go to the data. Then you go to the images. See, very simple. This one automatically I transfer to it because I'm in chapter 2. Okay, I'm right here. This will be this one. Then the name of the figure. And that was this one, you see that? And I add the extension PNG, .png, and that's the end of it. Okay, that's pretty cool. And then you can play with how big you want the pictures to look like, big, small. That's it. One time you learn how that works, and you are a king. So simple. It's you can use the same template in other places, or just copy it and modify it slightly, and then you feel comfortable. Okay, good. So, but the key point is really, let's look at the template. Let's look at the attributes. Okay, let's look at it one by one. Okay, household. By the way, when you look at a chart like this one, you see it's not symmetric ones. You see it's going up like this, and then it goes down. But then when it goes down, please notice this is a very common phenomena to a lot of variables in life. That's what we call a heavy tail or a long tail you might hear. You see the data is kind of start dragging down, down. This is a classical one. This is a very classical to a lot of variables. Many times to turn it to be a symmetric, you take the log, the linear log of the values, it will turn it to a symmetric. Usually it do the work, it do the job. So this is a very classical one. You can tell that this one is also beside this problem. I'll talk about in a minute. This one also, you see, it's not symmetric because up here, up to here, it's almost symmetric. But then from here, you see, it's like dragging, having like a tail. This one, it's a point, and I will talk about in a second. Okay. This one a little heavier. So some people do double log, but I don't like that. Don't do more than one log in case. And again, you have some issue. This one is a problem. This is look like symmetric, but definitely not a nice symmetric. So that's, but in machine learning, we're less concerned about it, by the way. We don't have to assume normality. We don't have to assume symmetrics. It's already that question. By the way, this one is totally, you can look at the latitude. I don't really care latitude. So latitude already tells you this is probably the area of Los Angeles, and this is probably the San Francisco, or vice versa. That's already what it means. So I don't really care about those two variables that much. Longitude, latitude is really just telling you location. Up north, longitude is if this really tells you if it's San Francisco or Los Angeles. This is if it's far from the ocean or close to the ocean. But it doesn't have to be normal. It doesn't have to be anything. The choose of those two variables. This one might be, but again, what really important is look at this line. It looks like, wow, a lot of, is a lot of the house's age is it's 52. That looks strange. That's what we call many times people, if there's a very old houses, they just say, okay, we stop at 50, something like that. That's what we call capping the data. This is really bad from analysis point of view. This is really destroying our data. Honestly, this is so we have to take care of this one. Should we chop it, throw it away, throw all those districts? Ideal, it's to go back to the people that provided the data and tell them, please give me the original data. Don't do it. I need the original data because that's very important information I'm losing. And that's quite a lot. Some things about this variable, by the way, when you look at the house value, especially this one, house value is the one that we're trying to predict. So somebody kept it up to half a million. Anything above half a million, it chopped it off. So if I'm interested on predicting houses that their value is up to half a million, then no problem. I can chop it off, throw it away, and just focus on these ones. But if I want to predict also houses that might be very expensive, this is distractions of this is really a bad distortions of the data. Ideal, go get better data. Ask someone to give you the original data and don't cap it. Some things here you can tell here as well. Median income. Somebody, there's two things they have done. This is not thousands, not 100,000. It's just scale from half to 15. And again, you can tell, you see this big, little, I took a little bar here. This is the sense that everything is above that amount, somebody kept it. So I said, any things above, I would just call it 15, and that's it. This is also bad, need to be fixed. So this is things that you really should pay attention when before you start analyzing. We have to deal with those ones, and we will deal with that in a second. Those are classical ones, okay? Total bedrooms, populations, total rooms. Classical, those ones you will solve by log, and that's very common in life, by the way. Very, very common. These are classical variables, which you might see in life. The solution is use a log, and it's turn them to a nice variables. So those have a problems, as we said, and we'll deal with them. And we have also missing data. So we have missing data, we have cap, we have to deal with. So let's play with it a little bit. Okay, now that we looked at the data, we know that houses we have up to 500,000 in case we have to throw it away. Here we'll say housing median age, it's up to 50 something years, okay? And we see there's 2 districts, 2 big areas. We're getting to learn a little bit about the data. It doesn't mean that we know already what to do with it. Bedrooms, total bedrooms, it's really kind of big variance. You have some houses have like almost 3,000, which is amazing. I don't know what people do with that population. And most of them is really right here. Some of them has big populations, but most of them are really like here, so that's not bad. Same things about those 2 variables, total rooms. Okay, let's move to the next stage. Let's visualize. Visualization is a very important one. Let's look at the map. So this is really also a good exercise to, how do we make a map? I think I don't know if I showed last time, I will go over it now. It's nice to know how to do something like that. It's very simple. In fact, I just took a map, an empty page, and I use the information from the table and plotted it. The longitude and latitude told me where to put it at. Let's say this district, for example, okay? I take the longitude, the latitude, the longitude, so I know what the location is. The size of the circle is the size of the population, okay? The color is what is the price, the average price of that district. So I have really 4 dimensions: latitude, longitude, the circle size, it's how big is the population, and the color, which is the price of the median house value. The more red it is, the more expensive it is. Okay, the more bluish or pale, that's less expensive houses in the district. So this is really nice to know. And there is, by the way, there is in Panda has some stuff, but I did really a little work for you. You can always use it. If you look at the exploration, I made, what did I do that? No, this one. This one is the histogram. Let's close it. Let's open the next one. Here we go. By the way, if you look at that, I will come back to this one in a minute. This is a very important topic, but I will get back to that. Okay. I want to focus on this one because this one I'm not showing you. Okay. I made a plot, a special plot for making something like that. See, this is in Algo. You can go to my function, the function that I did, or don't waste your time. If you don't want, you don't have to. Just understand what I did here. Okay. Longitude, latitude is the X and the Y. Okay. The population, it's what makes the circle. How big is the circle? The prices, it makes the color. Okay. Now, that's the name of the pictures. Is saving that pictures eventually. It's going to save it for me in this name. That's it. That's really what it is. Okay. Now this one, it's like a scaling. Yeah, let me just say, this is the scaling. If I didn't, it's scaling really the population. That's why I call it SNF. It's scaling for the numbers of population of the S. If I put 1, then all the circles will be very big. So I put 100, so I make the circles nicely. If I put 1,000, everything will be very small because the population will be a small numbers. This is a nice function to know that I edit for you. You can just use it and you don't have to go into the detail. If you ask me, it's really worth kill yourself. Okay, as long as you don't die, yeah? That's a joke, okay? This is a function I built for you, okay? In fact, it takes all those variables, as I said, and it takes the path, where to put it. That's plotting an image. By the way, just taking an image. It's an empty image. If you go to this one, it's an empty one. I think this is it, if I'm not wrong. Yeah, this is an empty one, you see? An image of California. So I use a library called MP image, is plotting it and give me a variable image. Later on, I use it. And here, if you see, by the way, you can see that the S here, I divide the variable S by the 100. This is just ready. But here, by the way, I'm using really Panda. In fact, so I'm using Panda to plot, and it is plotting automatically on whatever I called. When I run this one, it's already remember in the memory. The memory has the image of California. And then when I run this one, is automatically put it on top of it, okay? And you can get into the detail. You know, honestly, I did it once. I killed myself once and I forgot about it. It's just telling me a heat map is using for the color. And after I did it, I said, the hell with it. I don't even want to remember anymore. Okay. Color, just 1 second. Color bar, it's just if it put for you the color bar, so it tells you that the bluish, it's cheap, and red is expensive. If you want, you just change this to true. It will show you a bar there. I decided to take it away. Most of the time, you don't really need it. And do you really want as the X to split it? I said, no, just give me a clear one. I don't really care in those pictures. So this is usually what you do is I made my own plot, but I'm really using what Python has, okay? Then I change length to it, I give labels and all of that. It does it automatically, blah, blah, blah. You see, all of that is really just, it's a greedy stuff that you want to do. You do it once and you forget about it. And if you need, you go, this is one that I use my own. Say I'm saving the file again, and that's the end of it. Legend, to put the stuff on the right side, you put the font size. Do it once, go over it, read a little bit, and forget about it. Now you have a nice function, the algo. And that's exactly what we did here. We just used this, my function, I just put the variables and the hell with it and give me a nice picture. When I have the picture and it's already saved already, because in here I'm saving it, I'm just transferring it to this template. And this template is a very simple one, very similar to the other ones. Just put the image there, that's it, okay? So, but this is from the technical point of view. From us as a machine learning, what we really care is to look at the map. Look at the map, what do we see? We see that we have proximity to the ocean. It's raising the prices is more bluish, not always, depends. We see that there really is, there's two islands, I call them, not really an island in the sense, high prices. This is San Francisco, very high prices, Los Angeles, a little high prices in San Diego. This is San Diego, very high prices. And you can tell that closer to ocean, it's more expensive. Not always, not everywhere. By the way, this is very hilly. I don't know if anybody had a chance to drive. This is a beautiful drive, by the way. If you drive from San Francisco on the ocean, there is Highway 1, it's called. Beautiful, 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 beautiful. People don't live here, it's a cliff. You can't really build a house here even. Okay, so this is the closest, but not a big advantage. So the prices here are not expensive, it's just because you're far and not really that close, so it will affect prices. And this one is really the suburbs. Really, it has nothing to do with the ocean, but most of the people in California live around here, a lot of them, okay? And there's a range of prices. So you're getting an idea now what's happening here. A lot of population around here, big cities, 3 big cities, okay? By the way, really, just knowing that without doing any sophisticated machine learning, you can say, okay, if you live in a big city, your prices will be high. I can make that statement just by looking at the picture. Okay, you're close to the ocean, maybe high, not necessarily, depend. Are you in congested area? That could be a really important. Population size could affect the price, definitely. We see that here. Okay, so just by looking, it's really is, don't skip that stage. Many people just run, look for algorithms. And be honest with you, if I look for a house, I might don't run any machine learning, but we're going over that. It's a good exercise. It's an excellent exercise. But I get a lot just by looking at it. And looking, it's very, very important. By the way, this is the bar, as I mentioned before, if you're okay. So let's go into, and I think that the median house value, I did keep the bar for the population. I didn't keep the bar. There's several ones of them. You can play with it as much. There's other things I'm going to cover in a second, okay? Let's look at data exploration. And, why should I look at this one, by the way? I'm showing you the median. By the way, somebody I think wanted to ask a question. Sorry about it. Anybody have questions before I move on? No? Can I move? Can I continue? Everybody hear me? Anybody? Just one of you. You can unmute by clicking on release yeah. Can you hear me, Draman?
Yeah.
Yeah, good. I just want to make sure I didn't lose anybody. Okay, thank you. Okay. By the way, why am I showing? Why am I showing you this? This is such a subtle point. Later on, I will tell you that we usually will take the data. We have 20,640, and we're going to split it to two parts. Part we learn, and part we're going to test it. Later on, I will talk about even splitting it to 3, okay? For now, we'll split it to 2. And then you say, well, I studied in my statistical scores. If you want to take a subsample, just take it randomly. And I tell you, this is a mistake. It's a big mistake, in fact. And why? And that's why I'm showing you this picture. I took the variable of median income and I looked at it. Okay, by the way, you'll see the median income, it really is like, it's not thousands. It's just a scale from 1 to 5. And I will show you in a minute how I did it. But we know it's 1 to half to 15, if you recall, okay? And I looked at it and I tried to see how many people I have in each category, in those 5 categories. And I see most of the people are here in this third category here, the third one. Is those 2 really are the highest one, and then very small, low income. There is a high, but it's the second smallest and then the third smallest. So most of the people are here between those 2. If you take a random sample, you not necessarily will get in the sample the same distribution. If median income is a very important variable to explain why prices are expensive in an area, you would like to take your sample to replicate the population. Meaning, what I mean by that, if you look at the data, okay, you see that most of the people are in here. But if I take a random sample, it will be close to that, but it will be different. Moreover, could be even dangerous. When I take a sample randomly, could be even, if this is very small, I might not have anything. So this category will eliminate it in the data. So random sampling, it's not the right way to take a sample. If you know that one of the variables is very important, the best way to do what I call it stratified sampling. When I take the sample, I make sure that the sample will have the same distribution of income as the whole big sample. You know, I have like 20,640. That's I'm taking 20% of it to be like the test and 80% to be the training. So in the training and in the test, I would like the distributions of income to be very similar to this one. One more time, I will say that. I have the whole 20,640 districts. I look at the distributions of income, I get this one. When I divide the sample to two parts, training and testing, I want to make sure that in both of them, I will have similar distribution of income. That's why I'm not doing it simple randomization. So I might take the whole data, divide it to the whole 20,640. I divide it to 4 categories. And then each category, I will split to 80 and 20. That way I make sure that I have the same distribution. And in a minute, I will show you how we do that. Everybody got the point? This is a subtle point. Questions, guys? You know, if you have a big sample,
No question for me.
go ahead. Yeah, go ahead. No question? Okay. So this is a subtle point. And in a minute, in fact, I wrote, there is already a function in Python that does it. And I just even took it one step and made it your life very simple. Okay. So let's look at the code for this one first. This is the picture, I think. In fact, the one, I made these functions for you. And let's look at this function. And then I reuse it here again, because it's very important. Let's go and look at this function. You don't have to kill yourself. Okay, I do recommend Go. That's the way you study Python more, but you really don't have to. And don't be afraid to. By the way, I fixed, there was an error here and I fixed it, okay? This is an example I saw how someone asked, but he had an error. I fixed it. So this one I will give you later on. It won't make a big difference for you for now. Everything will work just fine, but I fixed it. You have to have a really good eye to know if there's an error. So I fixed that error right here. I will explain in a minute. I made a function here to do what is known as a stratified split. Okay, and I call it train test because I'm splitting it to two. I have a set of 20,640. I'm going to break it to two data frame, one for the training, one for the test. And I took a variable, I get the data. If I have a data, so I use it. If not, hey, we already have it. Remember the self data, that's the housing database. So I use the housing database. That's why I don't transfer anything. I don't need to transfer. But I tell him what the test size, I want 20%. That's very common. Later on, we will talk about what is known as a cross validation. Cross validation is a very important concept. So this is really just to warm up. So you get the ideas behind, okay? Then one thing is very important. I give you a field, a variable. And why do I give a variable here? If you look at this variable, it's already right here. If you see data field, I'm taking a column. Data for me, it really is the housing table. In the housing table, whatever field I give you, which is really, I can tell you, if you look at here, the field is median income. So I tell you, take the median income, take that column, and I use a function of Panda. Panda has a function called cut. Cut is very important. What it does, this is a very important line. Okay? It says, I have a variable which is it's continuous variable because net income is it's dollars basically, or in fact, it's between half to 15. And I want to break it to 5 categories. I want to break it to 5 categories. So data temp is going to be another new column in the same frame, data frame, but this one is going to be based on this column. This column, I said, take this column and make me a new variable, temporary, because I'm going to remove it later on, because I'm going to use it and then remove it. So, and I tell him, break it according to those beans. What do I mean by beans? If you look at here, I transfer those beans. What this means, I want to look at the data. If you have someone has an income between 0 to 1.5, call it number 1. That's why you call number labels 1. If his income is between 1.5 to 3, that will be number 2. Changes to categories. Between 3 to 4.5, call it number 4. Between that will be 3. If I have between 4.5 to 6, that will be number 4. And between 6 and above, that's infinity. That's by the way, how would you write infinity? So NumPy library just made a special number. They call it infinity. So you don't have to worry about it. Any number above 6, in another word, 6 and above, it would be number 5. So if I look at this line now, I can understand it. It means, look at this variable in the data frame housing, the variable name called median house. That's what we see here, median income. And look at that column. If you find a number in that one of the rows there in the income, if you find something between 0 to 1, put it in the first category. To 1.5, put it in the first category, the label. So the beans and the labels allow me to turn this continuous variable to a category number. So temp, by the way, if I printed it, I intentionally printed it, I wanted you to see it. See what the temp becomes to be, it's really only numbers, 5, 4, 3, 2, 1. I don't have all the numbers because it doesn't show me all of them. It would be 20,000 or something. So it doesn't really print all of them. But basically, this temp will have numbers between 1 to 5. So I have now categories. I took continuous variable and turned it to beans or categories. That's a beautiful line, by the way. This is a good line to learn. Okay? Okay. But say I took one step, I made a whole function and just transferred those 2 variables and make the job. I don't even have to remember it anymore. Okay? That's the beauty. Then the nice part, this is the hard part, by the way. This is one, nice to know. Then I made two lists. Those are lists. By the way, this is a little tricky. This is very important. This is new to you, could be very confusing, and we will see it a lot. So after a while, this line will be a little making more sense. In advanced courses, I will teach how to build one like that. Okay, how you make your own. It's you can call it an imputer, transformer, estimator. There's millions names. But this one, by the way, we're giving this from a library, Sklearn. Okay, there's a library here. And if you see here from Sklearn, we have model selections, import, and we're importing this function. It's not really a function, it really is a class. Okay, hard to really see what it is exactly, but that's really what it is. So what does it do? When I do that, I'm just building a class. I'm not doing really anything, but I'm telling him which kind of a class I want. By the way, this one, not necessarily. In statistics, I will talk about that. I will spend a couple of minutes on that one, okay, because it's really important. It's counterintuitive, okay? I'm telling him, build for me a class, We know what a class in Python now, okay? Okay, make this class, and I'm giving you a variable. It does have a variable inside this class. When I build it, it takes a variable called random state. Why do I give him random state? And by the way, this is a random number I made for myself, 42, I think I called it, but you can give it any name, number you want. Why do I need it? After all, I'm going to use statistics to randomly pick some numbers. That's what I'm going to use it in a minute. But so why I'm giving him a number and tell him use this one to generate random numbers. That's very funny. Let's say I tell you pick up two numbers from 1 to 10. So you might get 5 and 7, 3 and 8. Every time you get two different numbers. Is that right? What I'm telling him here, it's really counterintuitive. I tell him, choose random, but always choose the same numbers. So I tell him, choose randomly from 1 to 10, but give me always the same 2. That's funny. Why do we do that? It's only for us when we write a program and we want to test our data. So if I get every time a random number really, then I will not know if I'm making a mistake in my code or if it's really because, or it's just really random. It's a different random, therefore I'm getting a different result. So we would like when we do programming to put a random number to say, okay, pick once and always give me the same. That's it. Pick it once and remember. That's why I give you this number. So this number, it knows how to pick one set. But as for my training and all of that, I know I'm getting the same training set and the same sample test sample, and I can really check if I'm not having errors. When I finish everything, so I can go back and remove it, okay? And then it will give me really a random. I don't really care either, and that's I will talk later on. But this is very confusing. It's like telling him, give me a random, but every time, after the first time you're giving me, if I rerun this program, don't give me another random. Give me the same random as before. So I can test my code and I don't make mistakes. Okay, one more time. So it really tells him in these objects, and we'll see what it does in a minute, when you do picking up random numbers, pick it once and always give it to me. As long as I give you the same number, like this one is 42, if I give you 42, pick once for 42, and next time when I ask you random numbers with 42, please do give me the same one. That's what it really means. Everybody got it? This is really a little subtle. You can really ignore it, not crucial for this one when you just starting, okay? Give me 1 sec, sorry about that. Let me just take care of this one. One millisecond, I apologize. Okay. Okay, this one you will see a lot in other places. This is really good for testing and making sure you don't get lost. But just think about it. I just got once random and that's it. I will use it all the time. I'll use the same set so I don't really get lost. What am I building up? I'm building a class to split something. So this objective is to split data. But what am I telling him? Split it only one. Like you have one split. That's what the n splits means. And then I'm telling him test size, it really is like here I'm using 20%. If you see 0.2, I'm telling him when you split, whenever I tell you to split, please split it once and you make sure that one side will be 80% and one side will be 20%. That's really the split variable. The reason I'm mentioning this one because we will use similar ideas, okay, in the future. And all of them, they look like they're doing different things, but they have a very similar structure.
Hello, Amor.
Yeah.
I just want to ask one question. Can I ask a question?
Yeah, go ahead, sure.
I'm just talking about the random state. So if we test if we have to split the data and we are using 20% as a test size, so it means that using the random state, it means that next time when I'm going to split the same data set, I'm going to have the same data in terms of content. That means that if I choose, I will have the same people in my data. You mean I
Correct.
cannot change?
Correct.
They will not change.
Let's say you have 20,640. And if I put the same number here, the state is 42. I just put, in fact, I remember I put the random state in this
Yeah.
42. It means every time I tell you split with this one, always give me the 20%, the same ones. Don't change it.
Okay.
That's what it
So
means.
it means the same populations.
Exactly. But see, the first time he gave it to me, he does it randomly.
Yeah.
He associates it with the 42. And if I give him again 42, he will give me the same 80 and 20%. The same districts in our cases. The 20% will be the same districts all the time. It's not every time he does the randomization. He does it only once and that's it. And every time I run the program, he's not giving me a new one. Okay?
Okay.
Give me always 20 the same. This is good for testing because if I change, I want to compare algorithm and see, I know exactly that I'm always, it's not because this data is different. Okay. Later on, you can just remove it. Okay. And that's it. And every time you're random 20 and 80. And it would be hard for you to program the whole things. That's why people do it. And that's why they added it there. Okay, good. Now, let's see what the next one. Okay, now see, this is so important. This is a class. This is an object. We created an object using this class. Okay. Now I take this object, I use it. This is I'm using it. This class has a function split. And this function says split it, split the data. The data is really the housing table. Remember the housing? This is what the data is. Data is really the housing. Split it. That's what I'm telling you. And how is he going to do it? He's going to use this class. Whatever he does inside, he's going to use 80 and 20. So it means, in another word, I'm telling him, please split the data 20 and 80. This is really another word. Take this line and this line together. The other things is, and that's the important, that's why it's called stratified shuffler. He's expecting a variable, and I'm giving him the data temp. Remember the data temp? The data temp, we made it as a 5 categories. Remember, I tell him, make sure when you split 80-20, you have 5 categories of data in the data set. Each subcategory, make sure you'll have the same proportion. That's very subtle point, very, very subtle point, extremely important, improve performance big time. Okay, one more time. This is not a regular splitter of 80-20. It's not a regular one. This is the shuffler. That's called a stratified shuffler. And what does it do? It takes a variable. You can think about it this way. You know, I give him a data temp as a variable. Has 5 categories. So in fact, what it does, it takes the 20,640 divided to 5 categories based on this column. Each one of that category is splitting 80-20. This way, he ensures that this distribution in the training, in the test, and the total will have the same distribution regarding the variable income. Very important. Please do go over this code. And that's really what it does, is making sure that all the samples, the test, the train, and the whole population will have the same distribution of income. Otherwise, if I take it randomly, that might don't have the same distribution. And I want to make sure it will get the same distribution. Why? Because maybe I have expertise and I know that income is very important variable. If income is very important variable, I want my training to really replicate the whole population, test to replicate the whole population. And that's very important. It doesn't affect the performance big time if you really do have that knowledge. So I thought that this is very good, important point for you to know. But you can think about it now that you know. Please do go over and try to study it. Won't hurt you. This one a little trick. This is a little very important. It goes over all the 5 categories. That's why you have a loop for. It goes 5 times. You add them to a loop, to a list. And then what I did here is I do concatenate of all the 5 and put them together. So this becomes to be my test and the trend. And those one has the same distribution as we will see. Yeah.
So, but which variable are you trying to split? Is it the explanatory variable or is it the?
Yeah, this is one of my variables. If you remember, this is only one of my variables.
In the model, yeah.
Exactly, that I'm going to use. If you remember, when we look at the table, the get data, one of the variables is median income.
So are you going to do it for all variables?
No, it will be almost impossible. Usually you take the most important one, okay, and you will see why I think the median, we'll see the correlation. It means we get to a matrix of correlation, okay? You see there's a big correlation between the median of income to the house prices. What is the house prices?
Okay.
Because in this one, there's a big correlation. If there is a big correlation, when I do the study, I would like to know the distribution is the same in the training, the test, and the whole population. That's why it's a very important one. It's subtle one. You don't have to, you know, the bottom line, you can say, oh, good, Amos already did the work for me. I have a function, it does know how to do it. It does it, I don't really care about it, okay? And I just use it, and that's it. And that's, in fact, honestly, today, that's what I do. I can't really remember everything I did. So when I find this function, this is really just saying, okay, it will do inside everything for me. It will use this median, it will make it as 5 categories, it will split it, and I have 2 data sets. This is eventually giving me 2 data sets. If you look at it here, eventually, what do I get in the end of the day? I get a trend, a test, data set. The trend is 80%, the test is 20%, and it's nicely designed so to make sure the distribution of the income is the same. And I can forget about it, okay? By the way. Okay, there's one more function here. It doesn't really do much. It's just a cleanup. You can even ignore that. It just makes sure that it's dropping the temp. It's dropping the field. It's dropping the target field. Because what I'm going to do later on, now I have a training and a test. Is that right? I have 2 data sets. One for the training, one for the test. And then I'm running this function. All what this function does is it's really dropping the target field. The target field in our case, it is the value of the house. So I want all the variables that I'm going to use to explain the value of the house. So I'm dropping it from here, and I'm just putting it as a separate variable. You see, I'm just making a copy. This one becomes to be housing prices in the district, and this one, all kinds of data, not including the price of the house. The same things I'm doing for the case. That's very simple. So now what do I have? I have the training data sets, all the variables, not including the value of the house, and 1 column, including the house price. The same I do for the test. I have another, the 20%. I have all the variables here in this one, and this one I have another column which is only the prices. So this is really like one long column. This is one long column, and this is the metric. It's already a matrix. I should really say data file. Remember, matrix we use in NumPy. For now, we're only using Panda, and then later on we will see when we run an algorithm, he knows how to convert the whole thing as it should be. Bottom line, in fact, this one I call it from here. So I don't think about it.
Doctor, I have a question.
Sure.
I'd like to know if this process is the one we should follow or is optional.
See, this is really the reason I built all those functions. It's classical for, I would say 95% of the cases when you do machine learning. Okay, so, and the beautiful part of what we'll see in chapter 3, we will repeat a lot of those stuff. Okay, if we don't need the shuffling, then we just don't use the shuffling. So this line we don't need, so we just delete it. So if I delete it, it's gone. Okay, I can just, it's gone. And the only thing is if I don't use this one, by the way, okay, I just need to split it. There's other one, there's a other function of splitting, which I did here, by the way. There is a simple train and split. It doesn't have the shuffling, and that does the whole work and split and clean up. So that's a much simpler case. This one doesn't take into account that the distribution of the income will be the same in the three of them. That's a simple. That's really, that's what most of the people do. Which, if you really want to make a good predictions improve, that's a very subtle point, which is very important. Not always it's really the case. And if you get several variables, as Draman have said, then you ignore this, you don't do that, then all what you have to do is really, you go to here and just change it instead of train. That's the way, see, and how nice it will work. Just click that, and see, it will automatically write train. Yeah, I'm gonna have the train, ratified, and the regular one. Or just use this one. And that's it. And that will replace the one that I have. Okay, and I'm done. But I want to keep this one because here I'm using this one. In other cases, I just use the other function. That's it. That's the beauty. And it becomes to be elegant. The more, that's what I said the first time, the first course, go to those functions, learn them, understand them, even if you don't know the whole detail. But at least you understand what they do, and then you just go ahead and use them. That's what you really should do, and that's a good machine learning person does. Okay, very good. Now that we have all of that, by the way, when we printed the data on the California image, we took only the training data, but that's detail. It's really less crucial. Okay, now we finish with this one. Let's go to data exploration as we did before, okay? By the way, here I already did explain, I redid the whole things again, just to explain to you. And by the way, if you see, I reused this function. I used it before for completion, but this one is really just to show you in the data exploration. So when you see here, this one, it's really, I'm using only the training data, and that's why I redid the whole things again. Okay, let's look at other things that we did here. This is a very important line too. In fact, sorry about that. This one, the one before, this is also very important. But let's look at this one. What this line do? Okay, basically I take the train, which is now I have the data set, only the train. By the way, it's very important. After we split the data, I really put the test aside. I don't look at it even. You really shouldn't, because the whole idea is my algorithm is good. And the only things I should have in my hand is only the training. Usually in real life, we want to use the model to predict the future. In the future, we don't have. Here we use the test like for testing. So I really shouldn't look at the testing at all. So that's why I use the train. So I take the train that I made a copy of it, so I don't touch this one. And I take a correlation. I make a matrix of correlation. Everybody knows what correlation is. I assume that everybody knows.
Yeah.
Okay, is there anyone doesn't know? Correlation really, even if you don't know what it is, it shows you how close the relationship between two variables are, okay? So if you look at that one, it's really, first of all, you know what, maybe I will print it for you. Let me print it. I will rerun it and print it so you can see it. Run it again. Okay, let's look at the correlation matrix. There we go. This is the correlation matrix. Okay. Okay, you will see all the variables on the columns, all the variables on the rows, and the link on the diagonal. It all should be one, because every variable is correlated with itself. You know, every variable. So it goes from one. One is the highest, and all the diagonal, it's one. It's not coincident. It's just because every variable, it's really similar to itself. That's why you get it. Now, if two variables, when one is going up, the other one goes down always, it will be -1. When one variable goes up, the other one always goes up at the same time, that will be one, +1. So the numbers are moving in the correlation matrix between -1 to 1. So we can say, let's say the relationship between let's look at the column, the housing prices. Where is the housing price? Here we go. Here we go. The median house value. So this column, okay? I see here as a negative number. What does that mean? It means is that longitude. It means if you go up, the more you go up in California, the values of the houses goes down. Some things about latitude. The more you go to the west, the prices would go down, which makes sense because we saw if you go to the east, it goes down. Because we saw that if you're close to the ocean, which is west, the prices are higher. That's really what it means. Let's look at the other variables. Let's look at what this one, 111. This one is housing median age. If the house age is older, the price is higher, which is interesting. Okay, that's really what it means. Then let's look at the other one. Total rooms. Total rooms. Okay, the more rooms you have, the more expensive is the house. Makes sense. The total bedroom is also positive. Population. If you have a big population, the prices are even lower. So a big population doesn't mean you have a higher prices. That's really what it means. Okay, that's what we see here. Household. If you have more people living in the house, in the district, the more households you have in the districts, the higher the prices. Congestions in the districts. Okay, and finally, we're getting the most important one. It is really median income. The higher the income of the person that live in the house, the higher is the value of the house, which makes sense. This one tells us this is a very important variable. We have a high correlation. By the way, all the rest I don't really care because they are symmetric to this one, because this is the most important one. This one will be very important for when you do a regular statistics and you check for multiple linearity. But in machine learning, we don't really care. That's not the problem in machine learning. So we don't really care much about this one. We only care about this column. So how do I get this column? How do I look at this column? That's what we really did here. See, this is the matrix. I will take it away. I don't want to print it again. And then if you have a good eye, we take the matrix, we take the target field. What is the target field? It's the median house value. That's why we kept it there. We don't have to think about it anymore. He takes that one, he sort the values, he's sorting it up, goes from the most negative up to the most positive. It should really. This one I'm printing, so it's before the sorting. This one, I printed it before I sorted it, but it's really sorting it, by the way. If you look at when I printed, okay, I tell him sort it. Ascending, it means go from the highest to the lowest. So in fact, when I printing CM, I printing only one column. Why? From the matrix, this matrix, I'm taking only one column, the column of this column. I sort it, and I sort it descending. So that's really what I'm getting. That's interesting. And in fact, why is it so important? Two really numbers that have very negative or very positive are very important. Why? See, this one has a very positive one. That must be a very important variable. I shouldn't really give up on it. Another one, we have a latitude, a longitude, and this is not that kosher, but this one is kosher. Latitude, it means if I'm close to the ocean or far from the ocean. Okay? The further you get away from the ocean, your houses goes down. That makes sense. But it's not as important as this variable. Okay. By the way, somebody might say, well, Amos, you look at the total rooms. Maybe you should have rooms per household. So you take total rooms, divide by the households that you have. Maybe you get a better variable. That's called creating new variables. We'll do it in a minute. But for now, at least, we learn about correlation, the matrix of correlation. That's what we get here. And now I can really print it, by the way. And that's the beautiful scatter plot. I can even print those ones. By the way, I didn't really show it here. I only showed the matrix, the correlation matrix. I only showed it here to you, and I show you this data. Okay. Okay. Now what I did next is I generated some more variables. And let me go to the text and show it to you. Please do. When we read this one, we explain the whole things. We explain, and this one, by the way, I ran some stuff to show you that really the sample and the test and the training has the same type of distribution. So we can ignore that one for a second. Let's move on. Now I skip all of those. This one is really how you make the painting on the image. So I'm going to skip all of those. You can look at the code, okay? This one I will come back. I will talk about it in a second. What I really care about is really getting to here, okay? Getting to here. I would like, now that I looked at the metrics, I would like to look at it in my eyes, okay? And I take the variables that I can really see, the variables that are really important, okay? So I'm making a painting now. That's really what I'm doing now in the next one. If you see here, this is scatter painting. If you look, please do. Here what I did is I took some variables. I took the house median age. I saw it's important. We saw that the median age has a high correlation. What is that? House median age, it's 0.11. Total rooms, it's high. That's why I took total rooms. Total rooms is also, and I have median house value and median income. So those four, it's like taking this one, and the one that has all those three, by the way. The age, the other one are small numbers, so I ignored them. I wanted to look at the numbers that have high correlations, negative or positive, in this case, or positive. Took those attributes, I pulled them up from the database, and there is a function, very nice function, called scattered. It's also from the Sklearn library, and he make a picture for me. So what's wrong with that? He makes the picture and I save it. This is the one, it's saving it. And then I just, later on in the bottom, you will see, I'm showing it to you. Okay, so let's go down and look at it. This one is much nicer to look at it here. It's bigger too. And I can look at the three most important variables relative to the income, okay? Do we see which one really has the most effect, by the way? So let's look at it.
Median value.
Yeah, which one is really has like, see, if you look at this one, it looks like a positive relationship. You agree? By the way, it's symmetric. By the way, this chart is exactly this one, yeah? It's the same thing, it's just, if you turn it, you flip it, you'll get the bottom one, okay? It's symmetric in that sense. So that's, but so what do I really want to see? The median house value, how is this being affected by the median income? So the higher the income, the higher the value. That's why we got 0.68. By the way, but here it's very much clear. If you look at those dots, anybody wants to guess what those dots on the very top? Remember, we chopped the values of high value houses in $500,000. Those are the ones that were chopped. So if the houses are more than 500,000, we call it 500,000. So this line is worries me. I will have to deal with it. The same things in here when you look at the total rooms, how that affecting it. The same thing. This is also all the houses that are expensive one. So this is my destroyed really the correlation. I really should remove them and then do the correlation again probably. But for now, this is a very good, a good metrics to see how you can make pictures of several variables. I made only 4 variables. I put those 4 ones, and I made a correlation matrix only with those 4 and made the picture an image, not just to calculate it, to show really all the dots. And it's really hard to see this one, for example, the house median age. That's why we got a smaller number, like 0.11, I think. This one you have a little higher, but it's only 0.14, but this is really high that we saw. So we can really see that even in the picture, we can see that. I would like to really remove those one, and I would be still looking at this picture, it must have a positive relation. That must be a very important variable. Okay, let's see the next one. Here we go. Here I made the same picture as here. Just make it bigger. You can see it. You see these dots, something is fishy here. You must, by the way, they might have, if you have a good eye, you can tell, they might even have made a small category here. I can't really tell for sure, maybe here also. No doubt in real life, I would pick up the phone and call the person that prepared the data. Did they make a category here? And if it does, I tell him, please give me the original numbers. Something, this is for sure they did. Okay, so that's very important things. Some things about here 1, 2, if you can tell, room per house. Oh, here what I did is I made another variable. I took the rooms divided by the number of household, and then you get a new variable. And in a minute, I will show you the results when I do a correlation. In fact, you get even a higher correlation. And I wanted to look at the numbers. Honestly, it might has to do with this one. So, but at least you know that many times, after you look at the original variables, you might want to create new variables. So let's look at the code. Let's look at the code. We looked at all of those ones, as I said. Hold a second, where I was. Let me fill. We did that one. We did the attribute. This is good. Then the next one. Then we did the scatter one. Good. Now, this is very important. I made 3 new variables. How do you make new variables? Very simple. We have the training data. I can add more columns. This is a new column. I added another column called rooms per household. How did I do it? I took the column of total rooms divided by the column of household. So that's what I get, rooms per household. A new variable. Maybe this one will be a better variable. I took the total rooms, total bedrooms divided by the total rooms. Maybe this ratio is better than each one of those. Okay, I took the total population divided by the number of households. That also could be really interesting. So this really give me like an average per the district instead of just per house, you know, the total population in that district, that specific district, so there how many households we have. So could be really interesting. Can those variables explain better? So here we go. After I added those three, I ran again the correlation matrix. I have another correlation, and then I did the same trick. I took only the column of the field of the income, I sorted out, and I looked at it. So in here, that's why when you go here, you look at it. And by the way, it's really interesting when you look at it, you know, this is still the highest, the median income. The next one is total rooms, it's a 0.135. On the other hand, rooms per household is 0.1462. That's a little better. Maybe I should use this one because this has a bigger correlation than this one. So in my model, that might be a better variable. Or maybe I use both of them. I don't know, and let the algorithm decide. But here is a good example that I created a new variable, and this new variable has a better correlation with the prices, which is my target variable that I want to explain. Okay, so this is really interesting. This is really good. I think we covered a lot today, which is really good one. And then finally, I just plotted it. I did a scattered, blah, blah, blah. And that's really what I just showed you. And I made a picture, and here I'm just showing you the whole things. This is really the first time we're really touching the process of machine learning a little bit, really examining the data a little bit. That's all what we did, okay? Up to this point, it's just explore the data, visualize it, look at the correlation. Then we talk next time, preparing the data for machine learning. By the way, you see, I don't see anything here. And you see the whole printout is right here. And that's what we do next time. And this is really what you do usually is finally we see here something called a hot coding, one hot coding. We'll learn that next time. How do we deal with missing data? We'll use imputer, a simple imputer, median. I can do it manually. I will show you how can I do it manually. On the other hand, we'll see that there is a component that can do it for me. Usually I will use component, but to understand really how it works, this is a really good exercise, okay? And how do I find the missing data, okay? So in fact, what we will do next time is we look at the data, we try to find out where is the missing data. You see this column now, the total bedrooms. How do I find the missing one? I want to fill them up. I don't want to throw them away. Because if I throw them away, I lose a lot of information. Maybe I can just fill those one, take the median, and that's what we will do next time. How do I do it? I fill the median, and then after I fill the median, okay, I just look at it, make sure that I really did do the job correctly. And then I do the same thing, just use a built-in component. The beautiful about that built-up component, I just change median to a max mean or whatever, mean or median or whatever I think it's more appropriate. We'll do it immediately. I don't have to reprogram the whole thing. Here we will program. I show you how does it do it. And then eventually we have a data. See our data now, total bedrooms don't have any missing data, okay? And then later on we will say, okay, how do we take the categories, housing categories? Remember we did 5 categories? How do we present it in machine learning? In machine learning, it's not good to put 1 to 5. We have to transform it, and then we'll do it next time. And I will talk about it next time. That's where we'll start next week, and we'll see how much we finish next meeting, which we have, okay? Right after that, let's see if we can finish more than that. Yeah, this one is a bonus, I would call it. Those two is a bonus. I will do a lot in the pipeline. Pipeline is such an important topic. How to do a customer transformer. It's also very, let's say you don't really have to be expert, at least in the introductory course, but I do encourage you to learn them. Pipeline is very important. The beautiful is you take all the stages you do in preparing the data and you make them as one function kind of, and then bingo, you run it, it does the whole thing. That's beautiful, okay? Hopefully we'll finish those ones and then we'll start talking about choosing the model. Okay, guys, questions before we break? See, we're finally touching the course. Honestly, as we go along, I and Draman, we're learning how to teach this course. And we're even thinking about it. I think it might be advisable you take also software engineering too. At the same time, you take software machine learning too. But we're thinking about it and we're talking about it. And because eventually you want to be really a professional, and being a professional, there's no shortcut. That's life. But, and repeat, read again and again and again. Please go over the code again and again, read the chapter. And every hour you spend with me, you should spend 3 hours by yourself. That's the beginning. And then it gets easier. Take my word for it. I do stuff today so quickly. You know, sometimes people tell me how many people work for you. And I said, I have really 6 people. And we do so much work. By the way, Netflix, a big company, how do you know that they have a very good team? They have only 70 employees, programmers. 70 for a company like Netflix is nothing. That means they work very good. By the way, I built Academy City with the same platform they did. They use Django and Django CMS. So, and it's very good framework. It's very good, but it's a learning curve. The beginning is painful, very, very painful. Later on, it's wow. You say, wow, thank God I can do it. And it's beautiful. So, okay, good to see you guys. And we gather together again next on Thursday. Is that right? Couple days. Please go over this material. Please do. Okay? We'll continue from wherever we stopped. Have a good one. Thanks, Draman. Thanks, everybody. Anybody wants to contact me, you're more than welcome. So I was just last week, you weren't here in the beginning. In the morning, me and Sergey, we were looking at the accounting software. And I told Sergey, in my opinion, it's not a good idea to write your own. Although we found some Django, even somebody have written a software in Django, I still said, I'm not sure it's a good idea to take that one and use it. Maybe go and buy a professional software, but know how to connect to it. So if you are interested in accounting, this could be very useful information. I will be more than happy to share with you. Okay? Okay. Have a good one, everybody. Take care.
Hello?
By the way, Draman, good
Yeah.
news. Looking, I found another guy that can give me those 256 slightly cheaper, like $10 less even. So I keep searching. $10 or $15 less than what I told you. I think last time I told you about 50, or this one is like 35 or 40. So that might be worth to go on the 256 instead of the 186. But we'll see. It's a fast card, so it makes it really a nice computer. Okay, have a good one. We'll talk. Have a good one. See you Thursday.